Okay, welcome back. Sorry about that. My phone ran out of space. So, getting back, this is the air that we breathe in, and it has a bunch of oxygen in it. It also has carbon dioxide because we exhale carbon dioxide, so that's out there, and we do breathe some of it in. Also, there should be a ton of nitrogen here because that's what most of the air is, right? And there should be trace amounts of hydrogen, argon, all these other gases. But all we are going to worry about is we're going to worry about the oxygen and we're going to worry about the carbon dioxide. Now, when the blood shows up, so what the blood does is the blood has the exact opposite effect. The blood has a bunch of carbon dioxide in it. So here's the blood with all of its carbon dioxide. And there are trace amounts of air also. The blood doesn't drop off all the air perfectly, so there'd probably be some red blood cells that still have oxygen in it. So this blood, as it flows down, has a bunch of carbon dioxide and a little bit of oxygen. This air that we just breathed in has a bunch of oxygen and a little carbon dioxide. Now, that doesn't seem fair because what I see here is in the air itself, I see a lot of oxygen, right? Look at all this oxygen over here. And in the air in the blood, I see it's very low. That doesn't look like homeostasis. That looks like we need to level this out. So how are we going to level this out? Well, just like me stirring the water, all right, gases move around. They move around all the time, just like stirred water. So they're going to level out. They're going to try to make everything even. They're going to engage in homeostasis. So what's going to happen is, what if we pull some oxygen from the air into the blood and from the air into the blood? Now what I see is I see 3 oxygen and 3 oxygen. So what happened there? What happened is oxygen left the air and went into the blood. And why did it do that? Because before there were 5 oxygen and 1 oxygen. And now by swapping 2 and moving 2 over, we now have homeostasis, right? So just the idea of leveling things out is going to force this air where there's a lot more oxygen to even out with the blood. And the blood, we have the exact opposite effect. In the blood, we have high levels of carbon dioxide in the blood and low levels in the air. Well, that doesn't seem very fair. We need to level it out. Well, I see here I've got 3 carbon dioxide and 1 carbon dioxide here. What if one of these guys gives one up? Then now I see 2 carbon dioxide and 2 carbon dioxide. It's leveled. And wait, what happened right there? Well, what happened is carbon dioxide left the blood and went into the air. And now I see 3 oxygen and 2 carbon dioxide in the air I breathe. I see 3 oxygen, we'll put one of them on that dude. I see 3 oxygen and 2 carbon dioxide in the blood. And as this leaves, it leaves with a higher concentration of oxygen. It used to only have 1 oxygen, now it has 3. And as this leaves, it has higher concentrations of carbon dioxide. It used to only have 1 carbon dioxide, now it has 2. And also has lower concentrations of oxygen. It breathed in at 5 oxygens, and now it only has 3. So when this is all done, when this one little breath, this one little interaction is done, what is left is oxygen has left the air and gone into the blood. Carbon dioxide has left the blood and gone into the air. And the whole reason why did that happen? Was it magnets? Was it a cannon? Was it grubby hands? No, it's homeostasis. It is simply everything wants to even out in nature. So let's just see that one more time, and then we'll call it a class. So if I breathe in a bunch of oxygen, I don't know, let's go crazy. Let's say 9 oxygen. 1, 2, 3, 4, 5, 6, 7, 8, 9. And we'll say, I don't know, there's 1 carbon dioxide. So in the air, we're going to say the air starts with 9 oxygen and 1 carbon dioxide. So that's how it's going to start. And you can't see this. Let me move this over. Sorry about that. It's going to start, the air is going to start with 9 oxygen and 1 carbon dioxide. And let's say the blood, I don't know, we'll say it has, we'll say 7. 1, 2, 3, 4, 5, 6, 7 carbon dioxides and 1 oxygen. That means the blood, so this is the air over here, and this is the blood over here. The blood is going to start with 1 oxygen and 7 carbon dioxide. And that's going to be the start. That's when they first enter. So when the blood first enters this capillary, it's got 7 carbon dioxide and 1 oxygen. Didn't drop all the oxygen off. There's still some left in our blood, and that happens. And when we first inhale and all that oxygen, all that air gets into our alveoli, it has 9 oxygen and 1 carbon dioxide. Well, let's start with oxygen. What I'm seeing is 9 oxygen in the air and only 1 in the blood, and that doesn't seem even, so it'll even out. So how do we even out? Well, let's just start moving. If we move 1 over here, it's now 8 and 2. That's not even. Another one, 7 and 3. Another one, 6 and 4. Another one, 5 and 5. Oh, 5 and 5. That's even. That's homeostasis. So now, after this interaction, we're going to have 5 oxygen on this side. And in the blood, we'll also have 5 oxygen. All right? Okay, that looks good. What about carbon dioxide? It's the exact opposite in carbon dioxide. There's a lot of carbon dioxide in the blood, very little in the air, and those need to even out. So how do they even out? Well, I don't know. Let's see. So we have 7 and 1. If I swap that, it's now 6 and 2. That's not even. It's now 5 and 3. That's not even. It's now 4 and 4. 4 and 4. Homeostasis. Yes. So we are going to end with 4 carbon dioxide on this side and 4 carbon dioxide on this side. And then what happens? The blood flows on. The air gets expelled. We exhale. And this is what has happened. What has happened here? We started with, in the blood, we started with only 1 oxygen and we got 5 oxygen just from leveling it out. Notice these are identical. All we've done is leveled out what was in the blood and what was in the air. That's all we've done. Both have 5 oxygen, both have 4 carbon dioxide. But the effect is that the oxygen goes up in the blood and the oxygen goes down in the air, which makes sense because it has to go into the blood or we'd be dead. And the effect here is that the carbon dioxide in the blood goes down. We get rid of the carbon dioxide here, but the carbon dioxide here goes up, which is good. So it gets out of our body. So what happens? We get more oxygen in our blood, we get more oxygen into the air, and we stay alive. And the whole reason why, homeostasis. So if I were going to answer the point, this is what I would write. First, let's get rid of all this craziness. Okay, so how does the oxygen and carbon dioxide swap in the alveoli? And the answer is when the O2 and CO2 levels in the air and blood mix in the alveoli, so we have the oxygen and the carbon both in the air, and the oxygen and the carbon both and in the blood. When they get close enough together, they mix. When they can actually swap positions, when they mix, they even out, which we know is homeostasis, and oxygen enters the blood, and carbon dioxide enters the air. So it's not magnets, it's not a cannon, it's not grubby little paws or anything. The only reason that oxygen and carbon dioxide swap is just because there's high levels here and low levels here, and to even out, this has to pour into there, this has to pour into there, and they even out. It's just homeostasis. Thank you, and good luck.